High in the mountains of Costa Rica, an entire forest survives in a peculiar way. Mosses, ferns, and thousands of other plants blanket every branch. They capture moisture from the air and slowly release it to the forest floor below. Typically, each year, more than 100 inches of rain falls here. Yet plants throughout this forest are somehow drying out and growing brittle, threatening a majestic and irreplaceable ecosystem. To solve this mystery of how a forest this wet can die of thirst, we have to climb into the clouds.
When I started work here as a graduate student back in 1979, and I took my first visit into the Monteverde cloud forest, immediately I'm like, oh my gosh, look at all those plants and animals that are up there high above the forest floor. And I asked my professors, like, what's going on in the forest canopy? And they said, oh, we can't get up there, so, we really don't have much of an idea.
In the decades since, scientists have launched a new era of research by climbing into the canopy. And here in Monteverde, they discovered that these treetops don't simply sit beneath the weather, they live inside it.
A cloud forest is this unique type of rainforest where there's often a constant connection between low-lying clouds with the vegetation itself. The air is often saturated with water, and that's what allows for all of this growth that we see here.
The trees here stretch their canopies inside those clouds. In a normal rainforest, moisture falls down from above. But here, the clouds wisp their moisture against the bark, the branches, and the moss. This constant, gentle immersion provides the water this entire ecosystem depends on to survive. But despite all of that, plants in this forest are mysteriously drying out, and researchers are racing to find out why. When researchers see trees in distress, their first instinct is usually to check the health of the soil. But whatever is killing this forest isn't coming from the earth. It's coming from above.
For years, I climbed with really super simple gear. Just 2 Jumars and a couple of carabiners.
I invented a thing called a master caster, which is a big slingshot attached to an aluminum rod with a fishing reel underneath it.
Climbing gear and climbing techniques have advanced over the 40 years that I've been climbing. But sometimes I long for the early simple days. Back when I was young, by golly, that's all we needed.
Since Pablo's up in the canopy, it's a good idea to put your hard hats on now.
When you move just 100 feet vertically, you're suddenly in a place that is clearly three-dimensional, that you're looking down at the forest floor. You're looking up and you can see the sky.
Every time I climb the trees, now that I know many of these species, it's like seeing old friends. Yeah, it really feels like coming home in many ways. Hi guys.
Hey. We are in the upper crown of a gigantic strangler fig tree. Almost every living surface of these branches are covered with living canopy-dwelling plants.
There are hundreds of species up here, and many of these species are found nowhere else on the planet. They're a hotspot of biodiversity, and they really are a hub of life.
Right here, there's an orchid. People spend hundreds of dollars for a single orchid plant, and there's a bunch of orchids right there. There are orchids all over the place. And there's a lot of philodendron and monstera. These are the houseplants that we cultivate on our windowsills and our coffee tables in our homes.
Epiphytes are fascinating plants that build their home above the ground, in the nooks and elbows of towering giants. They spend their entire lives without ever touching the ground.
This shrub above me and over here, that's an epiphyte. This right here is an epiphyte. This right here that I'm moving, this right here, all of these things are epiphytes. Many of these are large epiphytic shrubs. They create a lot of the structure up here, and they are of vital importance for lots and lots of wildlife.
A single tree can host up to 200 different species of plants on its branches. But despite their abundance, scientists once assumed that they played only a minor role in the forest.
When I started out 40 years ago, the epiphytic component of forests were really discounted by science because the idea was like, well, they only make up a very small proportion of the biomass of the forest as a whole, so like how important can they be? And my entire graduate committee said like, that is a waste of time. That's a terrible choice. Why don't you study something important like something going on in the forest floor? And you know, for some reason, there was some gut feeling I had about, no, I think I need to stick to what I'm really excited about here, which is there are things going on in the forest canopy that need examining.
After decades of research in the canopy, the science has dramatically proven her right. It turns out that these epiphytes are a key to the very existence of this forest.
I tend to think of them now as what we might call keystone components of tropical forests, something that has a fairly small proportion in terms of amount, but a disproportionate importance in terms of the functions of what's going on up here in the canopy and in the forest. So even though they may only contain 10 to 15% of the above ground biomass of this tropical montane cloud forest, they're actually responsible for intercepting and holding on to, for example, up to 60% of the nitrogen that's coming in atmospheric mist and fog and rain.
These mosses and other moss-like plants can hold over 400% of their dry weight in water. It's hard to kind of imagine that, but I mean, you can, if we have them saturated, you could wring them out like a sponge.
But although these plants can hold an enormous amount of moisture, in Monteverde, many epiphytes are dropping their leaves. And because they help collect, store, and slowly release water through the canopy, their disappearance could spell doom for this forest. To investigate what would happen if these living sponges vanished, researchers turned the canopy itself into a laboratory.
This is the largest experiment of its kind. Scientists climbed into 10 trees around Monteverde and stripped them bare. Every epiphyte removed, every branch scrubbed clean down to the bark. 10 other trees were left untouched as a control.
This is the only experiment of its type in the world, is because it is a tremendous effort to remove all of this material from the tree. Our largest tree, it took 10 days to clear one tree, and that was with, you know, internationally renowned arborists who climb around the trees like monkeys, who are very, very good at what they do.
We did the experiment of stripping these trees in order to ask the question, what happens if epiphytes aren't here? And we could do the same thing by waiting 60 more years, but you know what? I'm 71 years old and I can't wait that long. So this really is critical because it allows us to ask questions of trees in the forest and to get answers to this question of effects of climate change without having to wait for those decades and decades to find out what might happen when climate change takes place.
We call this one Antiguo, the ancient one. This is one of the experimental trees, meaning this is one of the trees where we removed all the epiphytes. Every surface of this tree was completely covered. Thousands of individual epiphytes were removed for this study.
By comparing the stripped trees with those left untouched, researchers can see how epiphytes influence moisture, temperature, and the movement of water through the canopy. and measure exactly how these plants affect the forest's water cycle and its climate.
So in every tree, we have a microclimate station like this. So temperature, relative humidity, leaf wetness, solar radiation, and wind speed. And we have 4 of these in every tree. So that's the microclimate part of this research study. We have a lot less water here. And so what's happening is that the canopies are getting warmer. The increases in the cloud base, the increases in the temperature are actually going to be exacerbated by a loss of epiphytes. So losing epiphytes might actually accelerate the changes in climate that are already ongoing.
Epiphytes do more than keep the canopy cool and hold moisture. They also control the rate at which the water is released to the ground below.
Having a large savings account of water here means that when it rains, water can be held here, and then it trickles down to the ground, right? So that means that water is moving through the system more slowly, and that gives the soil time to absorb the water. If you don't have that, then water just rushes right into the streams. In the United States, we think a lot about snowpack. Do we have a good snowpack year? And if so, everybody's happy because that means water in the summertime for agriculture and human consumption. The cloud forest is kind of like the snowpack, right? It holds on to all this water that can be slow pulsed into the system year round.
Trees stripped of their epiphytes ended up hotter, drier, and far more vulnerable. Without these canopy sponges, rainwater rushes away before the soil can absorb it. Epiphytes are not mere decorations. We now know they keep this forest alive and healthy. The experiment reveals what the loss of epiphytes would mean, but it still doesn't answer the deeper question. Why are they disappearing in the first place? It isn't because the region is receiving less rain. Total annual rainfall in the Monteverde region is nearly the same as it was 50 years ago, more than 100 inches per year. The culprit isn't rainfall, it's elevation.
The changes in climate that are being experienced here in Monteverde and around the world are that the dry seasons are getting longer. There are going to be more days of the dry season where there's no rain and fewer days where there are mist and fog coming in. Because as land and sea surface temperatures increase, you're going to get a lifting effect of the cloud and mist and fog, and they're just going to sort of bypass where we are here in Monteverde and get up higher and higher in the mountains until they blow over the mountains completely.
This shrub has dropped all these leaves because it's undergoing drought stress just from the week or so of dry weather we've had. And this is the group that we're concerned with changes in climate because they use a lot of water and they're quite vulnerable to dry periods.
So basically this cloud forest in the future is going to experience much less mist and fog during the dry season. That means that those epiphytic plants will tend to dry out and perhaps not be able to recuperate because the intervals of time when the next blast of mist and fog comes in is going to be longer and later and later.
I often refer to epiphytes as the canary in the coal mine because changes in the atmosphere are going to impact the health of this community before the rest of the forest really feels it. Are these cloud forests under threat? Absolutely. I'm not sure we're going to be able to call it a cloud forest if we lose all the epiphytes. It'll be something else that will still be important in some way, but it's not going to exactly be a cloud forest.
Unfortunately, knowing why the cloud forest is drying out doesn't make the clouds come back down. Across the mountain, another group is confronting a different question. If the climate that this forest depends on is moving upslope, how can they give the ecosystem a better chance to survive?
There are people actually on the ground who are using the information that basic scientists like Sybil and me are creating, applying it to a real-world situation. Which trees should we be planting to reforest pastures?
This team is working to restore native forest across the Pacific slope of Costa Rica, where much of this land was once cleared for pasture.
We started in 1998 and we have given away over 310,000 trees, all native species, since then. We produce at least 18,000 trees a year, and it's not enough for the local demand.
They're actually applying what we learn about the basic biology of trees and soils and water and nutrient cycling in a way that farmers and landowners can reforest.
These researchers have been encouraged by how quickly these forests can begin to return.
We're seeing, after 15 years, we're starting to see the species richness and ecosystem functions really start to kick in.
No one knows whether restoring these slopes can help keep pace with the rapidly changing climate. But every new patch of forest gives the ecosystem more water, habitat, and more room to adapt.
When I think about the work that people who are doing ecological restoration, forest restoration, I really am so filled with hope.
So while we can't pull the clouds back down, maybe we could reach up to them. These canopies, as clouds are moving over them, they will capture moisture. And so maybe by planting here, we'll be able to help that some.
Sometimes people ask me, Victor, what are you doing? Planting trees is not going to change anything. Are you going to save the planet? No, I'm not pretending to save the planet. But I do what I can in my space. And in my space, I plant trees.
Restoring these areas has given us so much hope. These forests come back quickly. Work with nature, let it take its course, and they're coming back quick.
So I definitely have hope that we're gonna make it. Yeah.
I think ultimately what we as scientists really want to see happen is that it's applied in ways that are going to help the health, the flourishing of the landscape.
They're really important for ecosystem functioning and the health of the watershed, which goes all the way down to the ocean. Every time I feel like I'm awestruck. It is an incredible opportunity to be able to spend a lot of time in these canopies.
The ultimate future of Monteverde will depend on forces that are far away from this mountain paradise. But the people here are rebuilding their forest piece by piece to give it the strongest chance they can to meet whatever the future may hold.
Hey, before you go, we are really excited to tell you that the team over at PBS Eons just finished an amazing new TV show, and it's available now. Eons, Life and Death on Pangaea, has everything you love about the YouTube show and way more. The series tells the ultimate story of the supercontinent Pangaea during the Permian period. It was a time of massive geologic upheaval, full of incredible creatures, which all culminates in the greatest mass extinction in the planet's history. Check out the link in the description to watch.